going to do some stupid shit. Particularly, we're going to go over list comprehensions in Python, and then how to do stupid shit with them. That's really, really cursed. So we'll begin with the stuff I have already written out in preparation. This video probably won't be super long. I also have 2 more videos planned for today, so you know, we will see. So, it's 1:30 a.m. This is going to be a fucking amazing video. So, to start with, a list with numbers in it. Look, it's a list with numbers 0 to 4. It has 5 entries. It's a list. That's real useful, but like writing all of that out is kind of annoying and like cumbersome, and it would be real cool if like we could just change the length at any time and it would just do the thing. Let's make the list dynamic. Okay, so let's create an empty list, and then let's make a funny loop that goes through all the numbers from 0 to 4. Yeah, and then puts them into the list in order. Yay! Whoa, that's real cool. Or in like really funny, weird, we take the range and turn it into a list, which don't recommend that one. It's janky, but it works. Yeah, if I execute this, you can see, yeah, look, they're all the same. They're all the same. So then, what is list comprehension? So list comprehension, very easily put, is a way for you to do fancy shit in a list with loops compressed into the list. Basically, we're going to take this and with some special kind of writing turn it into just a single line of code, and then later we'll do some really weird shit and fit it all into a single line of code, because yeah, why the fuck not? So here we can now do I for I in range 5. And let's give it some let's just go with numbers. There you go. Also yeah, that should be fine. So yeah, look, it did the same thing. Whoa, that's real cool and stuff. Cool. What if we want the user to enter a number, and it does that for like that number? That would be cool, right? Well, okay, so it would need to be an integer of the input we got from a user. Yep, so we're already getting to doing this inside of the list, which is like, whoa, enter a number, 12. Whoa, 12 numbers, 0 to 11. That's 12 numbers. Let's say we're funny and we want it to count like a human does. So we do this. Now it's like 12, please. And now it goes to 12. I am caffeinated, have a lack of sleep, and very little plan where I'm going other than making increasingly cursed list comprehensions. So, next, we can do something else. So, this here is the normal for statement, right? And stuff, but this here, we can do stuff here, like if we want, we can do modulo 2 here. and now it puts every single number through modulo 2. So like, yeah, we can just make a whole ass thing here. Now, even more cursed is Python has Python has some cursed things where you can also put an if statement into like a single line if you're just doing a single if else and that's it. Also because that's just there we go. So we don't have to. So now we're at the stage where we type in 12 and we get something that for every even number makes it negative. That's neat. What if for every even number we actually wanted to output a list of j in for j in range I. Yeah, sure, that works. I don't know, 12. Yep, here we go. Now we're doing some real weird things. So, yes. This is already really cursed. Let's let's adjust this a little bit, shall we? Where does that bracket start? Where does it end? There. Okay. So there we go. 4k in k for k in that funny range. This is literally just this is identical to what it was before. It's just objectively worse. It does the same thing, but hey, it works. Now we can go through, and as long as this stuff isn't integers, so that this can resolve properly, we can there we go. Now we're doing even more cursed stuff. Now there's interspersed empty lists because, yeah, I guess a range from a number to a negative number with positive steps just doesn't work, so it just gives us empty stuff. So what if here we instead said that? How did that work? 12. Oh, now we have something. Theoretically, it should have the size 2, 4, 6, 8, 10. Does that? Oh, this would need to be the correct thing. So, yeah, there we go. Now we have some weird shit going on. Like this one just being fucking skipped. So then, we squeezed all of that into one line, and you might be asking, but why though? So let's maybe see if we can get something useful out of this. Also, totally ignore that I just clicked out. I totally didn't forget to go and do not disturb on Discord and get pinged just now. Don't mind me. So first, no, I'm not going to explain that one because like why should I explain that? It's horrifically convoluted and makes no sense. So like yeah. Yeah. You know, I'm kind of out of cursed thing to write now. But like, how about we write something actually useful? Did I ever? I don't think I ever explained how lambda expressions worked in the last time. Last time I did a funny video on these. Sure, let's explain what a lambda expression is. So normally you do a function and it's like define my func. It takes an x and it just returns 2 times x. Whoa. And like this is like cool and all, but like it's really chunky and kind of pointless. And like if we only need this like once to say apply over a list, so let's say we have a list and then we want to my func I for I in range 5. So and also yeah, so so now we're times 2ing all of the numbers in there. That's cool and all, but like all of this just so we can execute something complex here is not that nice, is it? So instead, what we can do is can I do it like this? I don't actually know if you're allowed to do it like this. I don't think you are. This will just give us an error, won't it? Yes. No. Right, this is giving us... right, so this is giving us functions which take... Okay. So basically, this is a short way of defining this. If I go my second function, and then just say lambda x, and then 2 times x, my second function is now identical to the first one. So if I do this, then we get something that's yeah, the same as last time. Just now we're using a lambda expression. These are basically like temporary functions, because the interpreter handles them a little bit differently. They're shorter to write. They're squeezed more. In general, just they're useful. Another fun thing is, if we go back to what I had before, which was this, so this will now make a very interesting thing, because now what this will do is this will generate a function where it's x times 0, then x times 1, then x times 2, then x times 3, then x times 4, and then we'll have gone through all of these numbers, and then the list will contain those functions. So then what I can do is I can now go and in another list comprehension, because that's just this video, we can go ahead and apply oh yeah, let's do it. For ij in enumerate numList, this will now be I will be an index and j will be the function. So what we can do here is this. So in this list is our functions. We number the functions, and just to make it more interesting, but we'll do this. We number the functions, which the I will be, and j will just be the functions that we've just numbered. So we take the function that we took out, and then we run the function with the number plus 2. So what this should do is this. So we define the first function, which is 0 times x. Right? Is that what we do? Let's see. So the first function is, yeah, it's 0 times x. So we grab the first function, and so we go 0 plus 2 is 2. 2 times 0 should not equal 8. I am very confused now. Wait a moment. This doesn't make sense. Oh no. We're not overriding it each time, are we? Be kind of funny if we did. Very easy way to test this would just be to see if all of these have the exact same address. The answer is no, they don't. So these are not the same function. Cool. If you want to learn more about memory addresses, go watch the C brain function, the C# video. Ah, there we go. It's like, no, sorry, not C#, C++. What the fuck am I saying? The C. Wait, no, did I make a video on C++? I didn't make a video on C++. Did I make a video on C#? Did I make... I don't think I did. I'm too tired for this. Anyways. Time to figure out why this doesn't do what I think it does. What if we do some shenanigans? Okay, so and then we want you to return ji, but also we want you to print I, and then you can be my function. By the way, in case you haven't noticed yet, this is entirely nonsensical coding that exists purely to exist. So yeah. Oh, what the fuck? Now it's working as intended. What? Literally nothing changed. We're still running J of I. If I do +2, that shouldn't change anything, right? But it does. But the first function is times 0. Like x times I, which I begins at 0. So this is literally a function that says take the number times 0. It should output 0, not 8. What's going on here? So I plus 2 is 2 in this case, so it would have to be 4, which means, is it? Oh, is this one of those things where Python just did something weird and all of these are technically the same lambda, even though they're at completely different fucking positions in the fucking list? Oh no. Oh no. Oh, I know what it is. All of these lambdas specifically use I, but I changes. So at the end, when this is done, I is 4. So all of these lambdas now have 4. Python, how I hate you sometimes. Also, fun fact, all normal integers in Python, like this 2 here and this 2 here, are stored in the same memory address by the interpreter, because the interpreter is just like, here's the list of numbers that are commonly going to be used. So instead of like reinitializing them so we can use them and stuff, it just has them pre-initialized and just points to them. Yeah, so here's the problem with list comprehensions. You wanna like do something like this? No. What if I make a funk maker? Oh, this is stupid. This is... I swear, if this works as intended, then I'm going to scream, because it's going to be one of those cases of Python just being a bitch. Now it works as intended. 2 times 0 is indeed 0. 3 times 1 is indeed 3. 4 times 2 is indeed 8. 5 times 3 is 15. 6 times 4 is 24. Now, you might be wondering, why the fuck does this work? Why does putting it out there work? Well, the answer is, by putting it out there, it's no longer defined inside of the list, and therefore using the local space of the list. This way, we're handing it down into this function, where now in this function, this is its own local variable, even though it has the same name. Like I could name this bloop. Bloop. There we go. And now you see the difference, because once it gets chucked in here, it's no longer this I, it is now bloop. Yes. And every time this returns, this every call of this function will technically have its own local space of bloop. Like bloop doesn't get shared by all of the lambdas, so now it works as intended. Yes. Anyways, the final curse thing would be to take all of this and turn it into one singular line. Which to do, we would need to simply take this bit and put it here. So there we go. That's already that. How do I solve this funny issue? Don't know if I can solve this issue of the funny local space. I mean, I might be able to make it a copy. Like explicitly tell it, no, make a copy, please. Is copy something in... No. Copy is not something in Python by default. The copy module exists. How do you, what's it called? Oh, it is literally just called, cool. Please, for the love of fuck, people, I know if you're used to like IPython or something, people love to put imports not at the start of the code, but like, why? There we go. We now make a copy of I, so this should now work as intended. If I... No. Module object is not callable. Oh no. Oh no. This isn't actually running as intended, is it? Does putting parentheses around it make it any better? No, of course it doesn't. This is the problem with cursed stuff. It doesn't like working as intended, you know. Oh no. Oh no. How do I make it not do that? So if you're still watching this chaos with no actual reasonable use other than I guess you know what list comprehensions kind of vaguely are, because I didn't actually explain them, I just immediately went down the deep end. Actually, never mind, I did explain them, didn't I? Yeah. Oh, never mind, you did learn something. Now you're learning what Lambda expressions are. Hey, aren't you proud? 25 minutes well spent. Also on that note, fuck, 25 minutes already? I need to potentially wrap up soon. What's the recording time at? Yeah, 25 minutes. Whoopsie daisy. So, let's see then. I want to turn this whole bullshit into, yeah. J run I plus 2, so that part's simple because this part wasn't actually needed, so I'm going to fucking delete you. We somehow need this bloop to be a thing, because right now this will do the thing where it multiplies all of them by 4 again. So also, yeah, so there's all of them by 4. So this one's annoying. I'm going to just comment it out. You no longer exist. Yeah, so funny that also just for the sake of my sanity and readability. Sure, that works. Yeah. This is cool and reasonable. Don't worry about it. Yeah. Is that enough space to make it nicer to read? Cool. It is now almost 2 AM. This is great. So I need to somehow have this I not be shared between all of the functions, and instead need to have it be its own actual value. So now my question would be, does doing something stupid like +0 here work? Because now it's no. Does doing something, wait, no, because we don't evaluate that in that case, do we? Yeah, no, we don't. Okay. Oh, no. I have an absolutely awful solution. For I, k in oh, this is cursed. Enumerate. So now this will be the ith k. And now we need this list to be a list of lists. So, yep. That needs to be the list of oh, this is awful. Oh fuck, where am I? So it needs to be this list is what we're enumerating for m in range 5. And if this is unused, we can just have it be underscore. If this works and doesn't just no, it still doesn't work. No, why? Why do you not work? You should work, please. Okay, let's go through this. So we have these lists. And then, oh, it's because now both k and I change, and I still changes, and so it's still, oh, that's really weird. Python, why are you like this? I can't. This is an issue that no other language would have, because no other language would be like, ah, yes, your function definition has just a dynamically changing variable in the definition that isn't part of the parameters, without it explicitly being a separately defined fucking function. What is this madness? Python, why are you like this? This is the height of stupidity, and we're already at really stupid comprehension. It doesn't even work. If this works, I'm gonna scream. No. Now I'm very confused as to why the fuck it's saying pop index out of range. because it shouldn't be. I swear to hell. No, pop index out of range. That's not... What? What? Heh. Heh. What the fuck do you mean pop index out of range? I don't like this. This is stupid. This is real stupid. So pop index out of range, you say. As we take the ith element of the kth thing in here. The kth thing in here is this is just yeah, list of range, whatever the fuck. So we have multiple of these in here. They have most definitely enough elements. So popping the 0th element in a list with 5 elements, aka popping the first element, should be perfectly fine and functional. Just in case, I'm going to do I-1, and it's still going to give us the same error because it's probably that this is giving us entirely empty lists for no apparent reason other than Python feels like it. So what I'm going to do, just to be real evil, is hard code the fucking list, because that just makes it more cursed, and we still haven't fucking index out of range thing going. So that's cool. Why do you not work? This is the point in time where you would not make this as a list comprehension so that you could actually debug it, because the problem is this doesn't allow you to slap print statements inside of it to just see what it's doing. So what I'm instead going to do is I'm going to take this bit and we're just going to put it here, make you just this, and then have you be printed, please. List index out of range in this one, but not the other one. Wait, what? Wait. Hold on, let's make this a bit clearer. I am the test. Let's actually spell it correctly. Behold, it works, except down here where it doesn't, because magic. Pop index out of range, except it isn't. Python, why the fuck are you like this? Now we're going to get... What? Wait, it works there, but it doesn't work here. What? Did I, like, put a comma in the wrong place or something? Like what's going on here? No, it's literally identical. It's identical. They both mark as the same thing. Oh no, what's going on here? Would it help if I gave you an actual name? Question mark. Is that why? No, it's still pop index out of range. This is why you don't do this kind of thing. Because one, have fun reading and comprehending this in literally tomorrow, and second, have fun explaining this, and third, have fun even making it work. And also, what the fuck is this? Okay, so it works. The test says it works. Mind you, the test uses an identical piece of code. This is identical. List comprehension works. It literally works right here. It's identical. Python, why the fuck are you like this? Is it just like, do we go too deep? I also just noticed we're using I twice here, so that might be why. So in this case, let's call this M, make this the underscore. Did that solve it? No. That might have been it, but not in this case. In this case, it would appear that popping on a list, which you output over here in this way, just refuses to work. Out of curiosity, if I call you I love my placeholder variable names that say literally nothing about the actual thing. So now if we had in here and I said, hey you, could you like enumerate please? What would that look like? Pop index out of range. Well, what do you mean pop index out of range? Huh? Wait, hold on. Am I stupid or something? Like I'm not being stupid, right? Like the test. I am test. Test works. So this works. Okay, it saved it in A, so that worked. And now it stopped. What? Huh? Huh? Oh my god, I have a feeling I know what it is. Hold on. I think I know what it is. Hey, you want to see something stupid? So in Python, there's this kind of thing, this kind of object that's called a generator, where you give it a thing and it'll like do a thing to it. No. So we know that this works, but it stops working the moment we put it in this enumerate. So if I were to say make a list out of the then it still stops working, but it stops working in this line. But if I just do that, then it works. What? What is this remote wizardry? Hold on. What is the type of is it a list or is it a generator? It's a list. My, that's interesting. That's real interesting. I wonder if no, it works, yeah. So then question. If all of this code is already run, pop index out of range suddenly in line 31. Yeah, so imagine having a thing, having it evaluate as existing, but then for some reason the moment you wait, what? Wait, what? In line 38, do this. But why? What? This is not a function. This is an object. This is just a list. Enumerate through the list. Why are you running it? What is this doing? This is a list. It's literally just a list. Python, what do you want from me? Please. Yes, it's just a list. Enumerate the list, for fuck's sake. What the fuck is it doing? Huh? This is not a function definition. I'm just not gonna investigate this further because it obviously doesn't lead anywhere useful, and it's some cursed bullshit that I'm not conscious enough at 2 AM to process correctly. So I'm just going to leave it here and say, thank you for watching, and see you. I'm recording 2 more videos now, so like by the time this one's done uploading, I'll maybe have finished recording the second one. See ya.